I've been asked by Double H Boots to design and develop a barbecue, and I came up with this design. I find it's a little too busy. This is my first sample that I laser cut. This is more of a package design concept because I have to figure out how to get a three-dimensional barbecue out of flat stock, 1/4-inch steel to be specific. To get a better understanding of my original design, I laser cut this out of cardboard at about 1/3 scale. This is my second model. I was really more just adjusting some of the relationship of the ring to the box itself. I tend to like this more where it hangs over. And there's going to be a center part that pulls up and drops down so we could adjust the distance from the fire. I'm going to get rid of these. This I'm going to get rid of, the skull, and I don't like this flame. I'm going to redesign this flame, go back to the Illustrator file and redesign a few elements of this, and then I need to make the grill in the front. And then I'm going to make another corrugated model to better understand it. And then everything's going to get cut out of 1/4-inch steel. Here you can see this is my third prototype. And the first time I'm cutting out the grill, that's going to be the featured graphic in the top and the middle. It's the Phantom Skull. And the reason I'm using corrugated is because it cuts super fast. And I'm not going to use these models. I'm not going to put them hard to the test, but I want to make sure that when I scale it to size, and this particular model is all cut to the right size. This is at 100%. The previous models were smaller, and I realized I just had enough cardboard so I could make it the full scale that I wanted to. It's 30 inches across once the grill parts are all put together. And it's 10 faceted sides. I got rid of the skull image on every other side in the flame. Now the flame that you see there is a redesign. It's actually pulled out of the graphic of the skull's face. So the skull, this is the ball of flame around his eye. So I pulled the graphic right out of the skull's head. And now here I'm putting it together. And there you can see I'm just throwing it all together. And I did the finger joints just to give it a little bit of interesting look. It also did help hold it together when I began to assemble it in real metal. I like this model a lot. It's less busy. We have the good branding on the top. You can see that. And then this is the adjustable turn height control. Pick it up and hit it against the stoppers. And then it falls into place, presumably. There you go. And you could raise and lower the height. I'm happy with this. There's a few elements I might add by the end of the video. I'm going to add some feet in the shape of boots. And I'm going to start working on my cut files for steel. 1/4-inch steel. Here we go. This is 1/4-inch steel. I buy it from Albany Steel Mill. I have it cut into 2-foot wide sheets, so it's 2 by 4 foot sheets. So every time I make my design, I make sure in Illustrator I set up all my graphics to fit inside of a 2 by 4 foot sheet. And that is so I can handle it. The sheet itself is probably hundreds of pounds, maybe 400 and 500 pounds. And I make the cut path in the Torchmate software. And now with brand new consumables, I'm getting a perfect cut. I'm cutting at 60 amps. I don't know what my feed rate is, but I usually set the file to 100 inches a minute, and then on the sliding scale on the app, that's on the actual program that runs it, you could slow it down or speed it up. So 100 inches a minute is just a basic starting point. And then I slow it down. Here I've slowed it down probably to 25% of that, which I guess would be 25 inches a minute. And it cuts perfectly. And you could adjust that when you get, I'll pull out this first piece and see what the slag is on the back, or the dross. And if there's too much dross, I'll speed it up or slow it down to eliminate some of that dross, which you're going to see me work on. You always end up with a little bit of dross. It's that afterburn that sticks to the back side of the plate. And that's the front of the cut. I don't know if I show the back, but you can see it's a really nice cut, nice even straight cut. And I made 10 of those grill parts that make up the full circle. And now here I am working on the featured part of the center of the grill. And it is the skull provided by them. And then this graphic I made up, this concentric graphic, I made it in Illustrator to radiate from. I just wanted to feature this, the skull graphic. And now you're thinking to yourself, the barbecue, how is the hot dogs and the hamburgers not going to fall through that? And I thought I could make the graphic really tight so that it doesn't have any holes in it, but then I'd start compromising the actual image. My solution to the problem was I have a woven piece of steel that I got at McMaster-Carr. A couple of years ago I made these little machine baskets, and those the woven wire, I'm going to weld a piece of woven wire behind this grill. And here you see I drop it on the ground a few times to get the dross off the back. And if the dross falls off, you have a good cut. But you still need to work it off to some extent. You got to grind it, shave it. Now here's a second piece of 2x4, and then here I make the rest of the grill parts, and then of course the 10 sides for the pot. I made 2 in the beginning, need to make some more. And you see me working on the dross while I'm playing just in between the cuts. And as many times as I use this machine, I sit and I stare and I watch it work, partly because I'm just babysitting the machine, but I am still amazed that this works. You're getting this hot plasma melting the metal, and the air blows away whatever gets melted, and with the CNC capability you're able to cut and make any shape you could imagine. Of course there are limitations. It's not a water jet. You can't get super precise sharp lines in some cases, but with working with what you know the machine can handle and what you know the machine can do, if you design your parts right, you can get perfect pieces every time. And there are limitations. The most I can cut with this machine, I believe, is up to 1 inch with an edge start. You couldn't penetrate the middle of a 1 inch or a 7/8, but with an edge start you can come in. And a penetration means where it decides where it wants to start, and then it just pierces a hole, and then from there it drags out the graphic. And there you can see a real nice image of the flame. And I'm just scraping off the dross off the back there by hand. Now, I've made this ring design before. I have a big fire pit in the yard, and I made a ring for a video. You could probably Google it. If you Google my name with barbecue pits inside of the YouTube app, you'll see a lot of different barbecue ideas I came up with over the years. And one of them was just that ring. Oh, thank you, Lincon Electric. One of them was just that ring that just sits on the edge of a fire pit. And that's why I was inspired to make this with a middle part that raises and lowers. Which, like I said, is not the most original design, but it's good with the graphic. That's what makes it unique. I tack these pieces together. I can get a big object out of small bits of starting metal, where I can cut a lot of little parts and then weld them together to make a bigger object. In this case, the 10 faceted sides come together to make the bottom of the barbecue pit, and the 10 grill parts. If the cut, for instance, was to give up in the middle and I had a problem, I can just replace one of the grill cuts with another little grill cut. It's another reason why I like to do it in segments. One long cut, you run the risk of potentially having issues. So by making them in smaller parts and welding them together, ensures you're going to be able to get what you want without too many mess ups. I find in the world of making things with a CNC machine, you always have a contingency plan or a backup, because technology isn't always 100%. There's always going to be problems, and you have to design in the fixes to those problems as you begin to understand what they could potentially be. Now here I'm welding every intersection where the round grill touches the firebox. Here I'm showing you that grill that I had from McMaster-Carr. I'm welding it in there, and this is going to be, it's going to serve two purposes. For the graphic that I want to try and highlight, it's going to give you a backer, which would make it easier to read rather than trying to read through it. Just reading light through it makes it a little bit more of a difficult graphic to read. Now I welded on the back grill, and I felt it needed a little bit of a bezel. The bezel would give it a little bit more presence and also hide the grill that is now showing around the open edge. And on the anvil, you see I just bang this 1/8 inch steel in the step, and I'm able to bend it into a hoop. And now I'm forcing it into the shape of this hoop. This is actually 22 inches now, and I'm forcing it and I'm welding it every couple of inches, and then I'm ensuring that this hoop's going to be a nice continuous hoop with a fair curve. And I was able to get that hoop without a metal bender. If you notice, I just banged it on the step of the anvil, and I got it close, and by opening and closing and just manipulating the bent steel, Here I am, and that's right where the two pieces come together, the ends come together. I'm just filling it with weld, and now here I am. I feel like that has a much better presence with a bezel on the edge. So ask yourself, where if you added a bezel to something, would you give it a little bit more presence? And you have the perception that it's 1-inch thick steel, when of course it's not. And now I'm welding my steps on. These are going to be the height control steps. And I weld right through the grill, right through the mesh. And I make sure I melt pretty deeply through the mesh. A lot of times when you see me weld on camera, you see me tack and then I go back in when the camera's off, because it's fairly boring to watch me just throw a big thick bead down. You're just watching lightning the whole time. So I'll tack on camera, then off camera I really get into it. And now here I am trying to decide where I'm going to put the stoppers. These are the pegs that are going to carry the grill. And I put a little 1/4-inch piece inside to raise it up to the height of the bezel. And these 1/2-inch rounds are going to become the pegs that are going to hold the grill up in the air in 4 points. I considered a few different mechanisms that would be mechanisms that you could turn or crank, but I was afraid there's going to be too much fire. It's too confined of an area. Fire distorts metal, and metal needs to move. So here you have just a few set positions, and I think it works fine. I'm using vice grips just to do this little demo, and I get a big thumb smudge in my camera. I couldn't get rid of that. And now here you can see I'm starting to get into the groove. I'm really starting to dig this. There's a real nice positive stop. Now here I am using my induction heater, and this is a piece of rebar. Just whacking that into shape. The induction heater is nice because you don't need to set up the forge to get just a simple bend like this, for instance. The induction heater I got on Amazon. It's about $2,000. It's the type of thing that you don't know you need until you have it. The best thing about it is you can isolate the heat. Of course, you see guys loosening bolts with the handheld one. You could certainly use that, but to isolate the heat when you're doing blacksmithing, it's actually really convenient, because when you blacksmith in an oven, you're heating the whole entire object. It becomes a loose piece of lasagna, so to speak. But if you're trying to make something like this, you can heat up just the areas you want, and you bend it right where you want it. And here, if that coil was tighter to the metal, it would get white hotter faster. And it gets white hot faster, but if I hold it to the edge, it also works, gets it hotter as well. And that's the same cut I used earlier, don't tell anybody. And now I'm ready to weld the handles on in place. Just thinking about, and I did not cut them with an angle. I'm just going to fill that angle in with weld. It's just a gut feeling. I didn't match or make sure they were the exact same. They felt the same, so if they look the same, they are the same. And here's me just thinking through the turning steps, and it works really well. If you notice, when I made those steps, I put a little notch on them so you can't accidentally turn it, watch it fall out. In my original sketch, I showed that these boots, which have the graphic of the Phantom Rider, I had the boots as feet to the barbecue. And here I'm just trying to think of how I'm going to incorporate the boots. I haven't thought it through completely. So I made a full boot, and then I decided to cut it to see how it would work in place. Here you can see the graphic of the boots in place. If you follow me on Patreon, I did a little story about how I actually came to the drawing. I took a photograph of the boot, and in Procreate on the iPad, I drew out a tracing of the boot, the actual photograph of the boot, and then that tracing in line art, I was able to turn that into vectors in Illustrator and use those vectors to be able to make the cut path. And here I am incorporating the boots as feet. Considering I made a 10-sided box, it wasn't easy to decide how to put 4 boots on 10 sides when every other one is the flame. So 2 are near the flame and 2 are not near the flame. It's not quite as symmetrical as I would hoped, but at the end of the day, there's a lot to look at. Nobody's going to notice. You got to remind yourself sometimes, as artists, we sit and we look and we ponder and we think of all the decisions that we need to make and what we need to edit, and we're assuming that the end viewer is going to be involved in all of those decisions and all of those edits, when of course they're not. They're going to just see the decision that we made, final, boom, that's it. They're not going to know the decision-making process we went through. They're not going to know all the good decisions we threw away that we still regret. Sometimes you just need to let go and go for it. So you'll see that some of these boots are near a flame, some of them are not near a flame. And that's okay. Because if you didn't hear this, you didn't know what I did. And here you see me struggling through with a set of shears. The shears are just a little too underpowered for this thick piece of perforated metal. I'm using it as the bottom of the barbecue so that if there's a fire in it, you want it to be able to move the fire around. You're not going to leave the fire in the grass. You can pick it up and take it with you. And I'm banging that circle, which will fit right at the bottom of the firebox. I'm banging the facets. I did a loose sketch of where each one of the 10 facets will be. And this way I could drop it down into the box and then weld each one of those facets into place. And this is inside the box. It's behind the scenes. It doesn't have to be perfect. But now I think I'm ready for some beauty shots. I have these digital fake flame light bulbs I'm going to drop in here and see what they look like. And there you go. I got a little key light just to show the box itself. Now the key light is turned off. You can see the graphic of the screaming skull. And there you go. There's without the key light. Now it's time to cook some hot dogs.